Hello students, welcome to another numerical in Newton's laws of physics. So let me read out the question to you. A bullet goes through a plank of thickness h and in the process slows down from a velocity of v0 to v. Find an expression for the time of motion of the bullet in the plank, assuming the resistive force to be proportional to cube of velocity. Okay, so let's find out the solution. So here it is said that a bullet is moving through a plank and the resistive force offered by the plank on the bullet be F. F is proportional to cube of velocity. So F is proportional to V cube. So we can write this F to be equal to K V cube, where K is a constant of proportionality. Now I can write F as mass into acceleration, and here on the right hand side I write K V cube. Acceleration can be written as dv dt. When I write this here, I get m dv dt equal to k v cube. Now I bring the constants on one side and I have dv by v cube equal to k by m dt. Now integrating both sides of the equation and taking the limits, I can write integration over dv by v cube is equal to, the constants will not be a part of the integrand, so they will come out, dt. At time t equal to 0, the initial velocity of the bullet was v0, and at time t equal to t, let's assume it to be v. So now if I integrate this, I know I apply the integration rule, x to the power n dx is equal to x n plus 1 by n plus 1. If I do that, here I will get v minus 3 plus 1 by minus 3 plus 1 in the limit v0 to v equal to k by m t minus 0. If I put the limits here, this will just dt integrated will just give me t. So now if I put this, then what do I get? So let me write it here. So this is v to the power minus 3 plus 1. So this will be 1 by v squared. Minus 3 plus 1 will be minus 2. So I will get minus 2 over v0 to v k by m t. So if I solve for t, I should get m by 2k, here 1 by v0 squared by 1 by v squared. So this is my expression for the time t. So that is all for this numerical. If you have any doubts, please write in the comment section below. Thank you.